remember this this week was like a one long day. We started as like a product who do some automation and UI for the cloud services. You found some really like old school software there. Like if we talk about this, like let's not forget about CF Engine.
This year will be definitely the year of AI agent. We will see a lot of interesting solutions based on
AI will replace everything and everyone, and like we're done.
Hello everyone! I'm welcome all on the first episode of the Dmytro Spodarets podcast. In it, we explore the world of technology, cloud solutions, infrastructure, and AI, as well as business, education, and sport. I'm really excited to kick off this podcast with amazing guest, Igor Savchenko. Igor is CTO and co-founder of Scalr, a remote state and operation backend for Terraform and OpenTofu. He is also one of the co-founders of OpenTofu, an innovation open source project in infrastructure as a code ecosystem that was created by community after HashiCorp changed Terraform license. During our conversation with Igor, we explored different DevOps tools, talked about infrastructure challenges and security. We also dive into MLOps, LLMops, and AI agents, discussed the future of infrastructure, made some predictions, and talked about whether AI agents could replace DevOps engineers. This is the Dmytro Spodarets podcast. Subscribe to us on YouTube, Apple Podcast, and Spotify. If you like my podcast, I would really appreciate for 5-star rating. And now, dear friends, here is Igor Savchenko. Let's start our small discussion.
Yeah. Hey Dima, happy to be here, and let's see how it goes.
Yeah, let's start from first very interesting question. Will AI replace DevOps engineers? Because this year many analysts say that will be the year of AI agents. So automation is going very quickly in all areas. And what do you think about infrastructure?
It's a good question. I mean, like, yeah, right now, like everyone talks and thinks about AI, and I'm asking the same question myself, like every day thinking about it. And I think there's a lot of hype there, like that, like, yeah, we'll like lose our jobs, and like AI will replace everything and everyone, and like we're done, Skynet, etc. So I don't think that, I mean, like maybe eventually in a 10, 15, 20 years, this will be the case. But I think right now, obviously, the most common use of like real use of AI I see around this like repetitive, boring jobs and tasks like, hey, give me the summary, or like maybe do some simple tasks. So stuff like probably like in the DevOps world, like stuff like what usually junior DevOps would do, like, hey, analyze these logs, find some things there, or like aggregate those metrics, etc. And I think in time, when AI will have like AI agents and AI will have access to more real-time data, to more different contexts, operational contexts that organization have, like more it will be able to do and help. But honestly, thinking that the AI agents will replace DevOps like in the near future, like I don't think that this will be the case. Like I'm just like maybe I'm too like pragmatic or pessimistic, I don't know, call like that way, but like when I'm seeing how in most organizations like deployment and DevOps and platform teams operating today, when you need to get like 10,000s of approvals and checks and reviews, etc., I'm not sure that AI will quickly replace this bureaucracy and those like guardrails in large organizations.
Yeah, in large organization, they have a lot of bureaucracy, but maybe a large organization also for speed up this bureaucracy, also start to use AI. And in some cases, we will have, in some future, we will have the situation when AI do all, and engineers will be the folks who manage this AI.
That could be, yeah, like absolutely that way. So like we'll all become like a managers.
Yeah.
But like in the near term, I see that use of AI can significantly boost productivity and efficiency of, let's say, DevOps and platform teams. So like with the same like amount of human resources, you can, and I hate to call like human resources, but like it is what it is. But like when you can, like when you have like team of 5 people who can do like way more than it was without AI, this is, I think, we'll see more and more. So like I like in the near term, I see AI not really replacing DevOps, but making DevOps more efficient, more productive, less mistakes, or even like things like troubleshooting will take less time to find the root cause of some incident or some downtime, like an outage, and quickly resolve it.
Yes, I think it will move in this way and help us to be more productive. As we start talk about productivity, let's talk about Scalr, its history, and how it helped DevOps engineers to be more productive by automating different tasks.
Sure. So at Scalr, we started a long time ago in 2000, like 9 or 10, and we started like exactly at the era where cloud computing became a thing, when Amazon released their first services like S3 and EC2. When there was only API, there was no console, there was not like any automation, and we started as like a product who do some automation and UI for the cloud services. And on top of that, like it was before the Amazon had like 10,000 different services. When there was only compute and storage, we would do like some, we would build some services on top of their like building blocks. And this is how we started. And we started the whole paradigm of like ClickOps, or and created the first product, CMP, cloud cloud management platform. Yeah. And yeah, and in 2019, this is where Terraform became like a popular, like popular before, but we started to see more and more Terraform, and our customers and prospects ask us like, hey, we don't want to do things like in UI and clicking things, like it's not really efficient, have a lot of problems, so like we want to automate things, we want to like write everything as code, etc. And this is when we pivoted to a product family, what we call TACO, Terraform Collaboration and Automation Software. Had nothing to do with like eatable tacos, but like, still fun. Yeah, and our current product helps you to you and like organizations to like to use Terraform at scale, where things like platform team would create like build a platform on top of Scalr that helps other developers and teammates in the organization to deploy things in a secure way at scale, with access controls, with audit, with a whole bunch of other things that you need at scale.
Amazing. And you not support only Terraform, you also support OpenTofu.
Yeah,
And this project changed the name. I remember that its was first name was Open Terraform or something like that.
OpenTF.
OpenTF, yeah. I remember when we work in one co-working, you with other companies start this project as when the HashiCorp says that they close the code of Terraform. How it was.
Funny story, yeah. I still remember this. Like this week was like a one long day, and yeah, we got a notification, and like all internet started to talk about the Terraform switch from like NPL open source license to source available license, which is not open source. business use license, which basically overnight prohibited like any competition in Terraform space. And like we decided that like, hey, like there should be some open source alternative, and a lot of like in our company and in other companies who started this initiative, there's a lot of like truly open source enthusiasts. So like one thing is like build business on top of open source, but another thing is like to contribute back to the community, like and believe in open source, like early days HashiCorp. And like we got a couple phone calls, couple of conference calls, and like decided like, hey, let's continue to have Terraform as open source alternative. And this is how we started like OpenTF initiative. And originally, we actually didn't want to fork. We created a pledge, and I think like thousands of developers and hundreds of companies signed the pledge, asking HashiCorp to like change this stance and get back to the open source roots, because like a lot of people contributed to Terraform over the years, and yeah, we like our ask was like, hey, leave Terraform. Like Terraform Cloud is commercial thing. You feel free to use money. You have a competitive advantage because you control the Terraform product roadmap, like in development. But then like leave open source itself like as open source, and we got like no response, so we decided to fork it. And then the first challenge was appeared, which is like, hey, how are we different from Terraform, from HashiCorp, and what will stop us to do the same thing? This is where Foundation come into play. So we decided to become a part of Linux Foundation because, interesting enough, in parallel with our initiative, Linux Foundation scrambled some conversation on what to do, because CNCF and Linux Foundation, they're using Terraform internally for a lot of projects, and they have a policy that they need to use like open source product. They cannot use like commercial products for like lots of things. And it weirds that like some of the open source, like good open source projects, a lot of them would use like commercially licensed open source, commercially like business use licensed source code, because technically nobody other than Hash's lawyers know like who can or cannot use. And it's like potentially it's like a legal exposure and a whole bunch of other reasons that I'm not illegal, so I don't understand. And I mean, like, we needed to win back trust of the community and build this trust, not to win the trust. And this is why we decided to become part of Linux Foundation and eventually CNCF. And Linux Foundation was super happy about it, and we created a trademark, picked the name that was legally acceptable. We can use OpenTF, so we get like if we use OpenTF in theory, we can be sued by this. So we found a neutral name and give all the rights and permissions and trademarks and intellectual property back to Linux Foundation. And then we, with other vendors, sponsored the project by hiring the full-time engineers to work solely on OpenTofu based on like community requests, most requested features, bugs, etc. And this is how it all started.
Yeah, it's cool. And for now, what is different between Terraform and OpenTofu?
I mean, like the biggest difference I think is OpenTofu is a fully open source license.
Yeah.
It's still like
Yeah.
Mozilla
About
public license, etc. About features,
Yeah, about features.
so we started as a first major release was like it was fully compatible, and still a current release. They're all fully compatible with 99% of Terraform code base and feature wise. But we started as like maintaining feature parity and compatibility, so it was not like that different. Because again, like we still are thinking about like how people migrate from Terraform to OpenTofu, and less like non-compatible things today will have like easier it will be to migrate. But then like over their next major releases, we added like features that were like for years, some of them for 10 years requested by the community, but never, like always ignored by HashiCorp. Things like state encryption. So now, when you use Terraform, your state is not like a plain text file with a lot of secrets. It's actually encrypted. Yeah, and recently our I think it's 1.9 release, we added for each loop for the providers, so you can easily walk through multiple instance providers, provision and things without like much code duplication. Like if you want to deploy something in multiple regions, for example, you just define one block and use for each to deploy in multiple regions. There are many use cases like this. And before that, there was another limitation of the Terraform, which is you cannot use variables in modules and provider definitions and configurations. This is, I think, was like top three features that are requested by the community, and we also added it. So we continuously listen to the community, and it's good thing that we had like a good history of what community wanted us to do, and what like Hashi never found like time, resources, or will to do for whatever reasons. This is our focus, and we'll see what future will bring to us.
For today, how community start migrate to OpenTofu? Is big companies still use Terraform or start to look at OpenTofu and use it?
Good question. So, like, we have only like anecdotal evidence because, like, hey, we don't really collect any data in OpenTofu, no telemetry and other things. So we actually don't know like the actual like magnitude of use. But like from within my company, for example, we see a lot of like Fortune 500 companies, like big enterprises, started to move to OpenTofu, and doing this pretty efficiently and quickly. And then we have a lot of customers who come to us and started to use OpenTofu from the day one. So I think it's still like after a year, we get in this like question like, hey, what about providers? And like, unfortunately, there's still like some like misconception, misunderstanding, like that OpenTofu is not very different from Terraform. In, I would say, 99% of cases, the migration is as easy as you just switch the binary from Terraform to OpenTofu and it just works. Especially if you haven't used this new Terraform specific features like stacks, for example. So in most of the cases, migration is very easy and quick, and it's the same providers. They're still open source, and like there's a high likelihood that they will continue to be open source for like different reasons. And yeah, I think in cases that we see like why migration can be slow, or even like some companies not willing to migrate, is not really technical reasons. It's about risks and some politics. So for example, first of all, like we're a new open source project, so we need to build a trust that, hey, we can maintain, we can fix the bugs. So in a lot of companies, when they start using things, they use it like for years, and nobody want to make a decision to migrate to a tool that then suddenly they cannot use for whatever reasons. Then another one is support. So like, yeah, with Terraform, you have like enterprise support from Hashi, and it takes time to build like a number of vendors who offer the support for OpenTofu, commercial support. And companies like TerraGrant, for example, Grantworks, who are creators of TerraGrant, I think they're doing an amazing job of like supporting OpenTofu and deploying OpenTofu for their customers. So yeah, takes time, and we continuously see a growth and continuously see the companies who migrate, and more companies trust us. And I think it's a matter of time until like most of them will break to OpenTofu, because guess what? There's no reason not to migrate.
Yeah. And what about cloud providers? They have their own models for Terraform. If they migrate or change the models for using
So
directly in OpenTofu?
probably you mean providers.
Yeah.
Providers, yeah.
Cloud
So
providers.
cloud providers, yeah. So cloud providers. So first of all, they're also Mozilla public license, but they're open source, and we don't believe it's current understanding that it's impossible to change the license because when cloud providers were developed, Hashi didn't ask for CLA. So technically, if they want to change license for any of the provider, they will need to get a permission and approval for every single contributor who ever contributed to the provider, which is like, I think it's a heavy lift. Now, in terms of compatibility, it's using it's using the provider protocol, and in like it's the same. So and at OpenTofu, we're doing like a pretty good job maintaining all the new features and like and changes in the protocol. So all existing cloud providers and providers out there can be used in OpenTofu as is without like need to change anything.
Yeah, OpenTofu, it's one of something new in this era of growing DevOps and infrastructure. Also, on the market, we see different other tools like SDK, something like Pulumi comes. What do you think about this solution? How they will change the infrastructure world and DevOps?
You know what? Like, it's a great question. Before that, we had like cloud specific things like CloudFormation, Bicep from Azure. Then we have Pulumi. Then we have Terraform SDK, and a whole bunch of other things. And like, like there is no ideal solution. Like, and every single time, like I know this mentality when like, hey, there's like nothing ideal, so I'll create a new one which will be ideal, but it's ideal for me, and now we have like another one and another one. Or like from cloud providers, it's about control. So like I believe that like cloud providers, for example, they have like CloudFormation and Biceps and their own tools because they want to control like how their infrastructure has been used, and like they don't want to be like they don't depend on other vendors on like how infrastructure can be deployed, because like other vendors can do like all sorts of things and create a preference. So for example, let's say if we won't be part of like let's say Linux Foundation, and we can do whatever we want to do. Let's say Azure would like sponsor certain development to make their provider faster or better. And in a world where net neutrality is no longer a thing, like it's absolutely possible. So theoretically, it's possible, and that's why I think cloud providers have their own solutions. And again, like some people think that like, yeah, why we need to learn like new language? Why we cannot just write? Why I cannot just write my infrastructure definition using JavaScript, TypeScript, Python, Go, PHP, whatever Java language you want, like. And yeah, some prefer that, but I still believe that like de facto, I think Terraform and OpenTofu are the market leaders, and I think like 80-90% of the infrastructure has been deployed through them in one way or another, or like we're moving towards this direction. And this is another one why it's so important to have like an open source solution, because like it should not be controlled by one entity, one company, because everyone can do whatever they want these days, unless you're part of foundation.
Yeah, it's we have different solution, and it depends what we want to solve, what's the problem. Because sometimes SDK using more better if you want to have control of your infrastructure in your application. But it's not very good, for example, if you use in same way as you use Terraform. So write some specific application which will be same as Terraform. why to do this.
Yeah. It's I don't believe that there are like a bad solution. Like some believe that like some languages are bad. Like hey, Python is bad, write everything in Go. Hey, Go is bad, write everything in Rust. I don't believe like bad languages or like bad solutions. There are like place for all of them in some way or another. And I'm pretty sure there are companies and problems out there that perfectly well solved by Pulumi or by CloudFormation. But then when we talk about like all the variety of different use cases and variety of different like constraints and environments, I think tools like Terraform and OpenTofu, they absolute leaders.
If we speak about solutions such as old tools like Ansible, Puppet, Salt, companies are still using them for a long time. How do you think they are relevant today? Companies often use clouds, and for configure the cloud infrastructure, it's better to use Terraform or OpenTofu. What do you think about this?
Yeah, you found some really, really like old school software there. Like
Yeah.
if we talk about this, like
I
let's
remember.
not forget about CF Engine. Yeah, look, we still can use like a laptops to put a nail on the wall, right? You can do this, yeah, absolutely you can, but I'm not sure that it's designed for this thing. The same with like Chef, Salt, Puppet, Ansible. We need to remember like how they started. They started to configure stuff within the application, like on a operation system level, when you can configure, for example, fleet of VMs, fleet of machines, and manage them, deploy like configure operation system, like install patches, and they're very good at it. And even these days, I'm not sure that there is like solutions better than that. When you need to manage fleet of like thousands of virtual machines and clusters, etc. Uh, then before Terraform, I know that like things like Ansible and Chef, they expanded to like, hey, if you can deploy certain applications within OS, why you cannot deploy things in cloud? And they added this use case when you can deploy everything, like deploy infrastructure in cloud, and then within this infrastructure configure it. But it's a solution on top of existing solution for different problem. It's like, yeah,
But they
you,
also have some functionality for deploy some virtual machine in the
of
cloud,
course,
and they try to, in some part, um, duplicate the functionality which you can do using OpenTofu, for example.
of course you can do this, but I'm not sure like if we talk about like efficiency and productivity and maintainability and support, like hey, simple example, like the guy worked in an organization and he's like Ansible got there and he can do everything in Ansible, and he wrote like 1,000 lines of code of deploying everything with Ansible, and then he happily retired and decided to spend time with his family. Now you need to hire like a new people to replace him, or you grow the organization. I mean, like, good luck finding all these DevOps who are willing to manage infrastructure that way.
Yeah, it's a very funny situation where all knowledge is only all knowledge of infrastructure have only one people man, and then he leaves the company, and the company, oops, we don't know what to do.
Happens all the time, and that's why it's like, I mean, like, it's possible to do that way, but you need to think about the future, how like you'll need to maintain it. You need to make sure that like when you have like new people come the company, they can actually understand and maintain and write this and continue to maintain this thing and improve and evolve. And if OpenTofu solely focused on making infrastructure deployment fast and efficient and secure, and declaration of it like simple and very well like understood, then if the same thing is possible with like, let's say, Ansible, but it requires like more time, more lines of code, it's harder to understand, etc. And then like when your infrastructure becomes like more and more advanced, when you started to use all this whole bunch of services, microservices, and when it grows like exponentially, which happens all the time, like what happens on like not a day one but day two, then five, then day 10, you need to think about it.
Yeah, I think these solutions were good for some local infrastructure for on-premise servers because using them you can configure these servers as you want, and this solution was created for this. So yeah.
And honestly, I'm still seeing a lot of companies who using Terraform to manage and deploy infrastructure, and then Ansible to configure it afterwards. So they actually Ansible and Chef and other things are super nice to actually, if you're still using VMs these days or bare metal servers and you provision them through cloud or through Terraform, it's still like a good solutions that works perfectly well with OpenTofu and Terraform to do the data operations.
Yes, to take companies. I remember that was the hype when the companies start to go to the cloud and all infrastructure they want to have in the cloud. But now we see, I think, on the market, the large enterprise understand that the cost, the bill of the cloud is very high, and they start to migrate on their own data centers to provision the infrastructure there, and in some cases they try to use different clouds, and we have multi-cloud and hybrid infrastructure. So what challenges you see on this area, and what you see on the market?
So, like, first of all, yeah, your cloud bill can run out of control like super fast, and that's why it's important that in early days you set the right proper mechanism and proper guardrails how this can be utilized. And then, like, I believe that like going multi-cloud just to save cost, I wouldn't do it honestly, because like I think it's a myth that you can easily go multi-cloud and like the same code, the same definitions will work across multiple clouds, because honestly it's like that's bullshit. And like when going multi-cloud, your complexity of your infrastructure, complexity of your code that manage this, and knowledge, it's all pretty much exponentially grows. Like it's not even twofold, now it's like fivefold. And the only like I seen the companies go multi-cloud not because they made a decision, but through a bunch of acquisitions. Like, hey, I'm let's say Amazon user, but then we acquired this another company, and historically they use Azure, and then we acquired another company, and then historically using Google, and this is how like organizations become like multi-cloud. Very common thing. And yeah, the same what happens when like this organization managed like this business unit who we acquired last year, like they're using Ansible for deployment, and this one using Terraform, and another one using CloudFormation, and now you have a huge mess that's very hard to deal with.
Yeah, and other good topic for clouds and for multi-clouds and hybrid infrastructure, it's security. What challenges you see for now on the market related to security?
Yeah, like it's funny because like the recent debacle with DeepSeek AI, when they left the entire like access to the database exposed to the internet, where you can query all the like no privacy, nothing. Like this is a great example of I don't know how they deploy and how they maintain security. Maybe they don't at all, but that's a good question. And again, this is why you need tools like Scalr, like others. When you have a lot of people, a lot of entry points who have access to provision infrastructure, unfortunately, people forget things or they don't know about things. Also, like some defaults somewhere can be changed. So you can do this through code reviews, for example. This is like first line of defense. Then it can done with different tools like Checkov, TFSec, Open Policy Agent to prevent bad things to happen down the line. But in organization, somebody need to configure this safe environment where you can write your code, deploy it, and you will give and the platform system will give you some response on like, hey, you forgot to change the visibility to this like bucket to private, so it won't be exposed to the entire internet. This is why, like, I think today you probably heard this term of like platform team. This is how like why platform team exists, is to build like a platform for internal consumers developers that you can use to provision wherever you want in a way where it's secure, where cost is under control, but at the same time with a lot of like self-service like approach where you don't need to go through a whole bunch of approvals for every single change you want to make.
Yeah, the way to have some internal platform team and some internal platforms where you can go and very quickly create some environments with all rules and you don't need to get the approval. It's really speed up all development process. AI is everywhere today, and all companies want to use AI in their solution. Whether it's classic ML models or popular LLMs or new AI agents. So DevOps need to build the infrastructure not only for solution but also for AI specific. What do you see from OpenTofu or Scalr side in this way?
Actually, maybe that's a good question for you because like at Scalr, we haven't seen much of this yet. But what do you see on the market in terms of like how organizations who want to do like AI and agents, how do they deploy things and make it secure?
Yeah, I think it's a great question and good topic on which we can spend a separate episode. But let's quickly talk about how companies today work with AI models. Um, for managed infrastructure, companies today using MLOps. This is the same as DevOps, but for machine learning models. The new version of MLOps, it is LLMops. It's as you guess, I think it's about operating and work with large language models. MLOps, it's not on the list of these tools. It's the same as DevOps. It is a practice. It is rules. It is agreement between teams, how they work, and what the process they have. But from tech stack side, it is a really big list of different tools and solutions which need to have in your infrastructure to operate machine learning model, because it's only the machine learning model, it's small piece in this big AI solution. So what we need to have in our infrastructure for operate and create the models. First, we start from data. So we need to have the place where we store data, the tools for labeling data, some tools for do versioning of the data. Then, when we work with AI models, we have two different type of environments. First environment, it's experimental environment. On this environment, we create the model, we run our experiments, we track the parameter of the models, so a lot of stuff, and we need to have big compute for this environment. From other side, second, it's production environments. And in production environment, it's more about operate machine learning models in production, do deployment, do monitoring. Also, we need to have some pipelines which help us to get feedback from our from our model, because from one side we get feedback automatically from logs, for example. From other side we need to get the feedback from real user and check is model give to them correct result or not, and collecting all this data, then machine learning engineers, data scientists improve the model and publish new version. And if we talk about LLMs, then we need to add more different tools specific for LLMs. First of all, it is some frameworks like LangChain, Llama Index, which help us to build the interface between LLM and our solution. And we built our solution like RAG system or other based on LLMs. We need to have and work with vector databases. We need to have the tools which help us to do prompt engineering and prompt management. It's we need prompt engineering. It's like we do some experiment with our prompts which we send to LLMs and use in our system and check how it works. So we need to have this this part in ecosystem. Of course, we need to have the tools for LM evaluation, and of course we need to have the tools and tools for provide security of for LLMs, because nobody don't want to share with some public LLMs if we use some provider, some critical and private information. And if we use internal LLMs and this LLM have access for some private or very critical information, and some user of the system don't need to have the access to this data. So we don't want to provide this data through LLM. So we need to monitor and analyze what data LLMs give to the user.
And so, like, from what I understood, like MLOps or LLMops, it's like not very different from like standard DevOps practices.
Yeah.
You still need to deploy stuff. You still need to make sure that it's secured. I have no idea how to make sure that your bill won't run through the roof by running all these billions of like tokens, etc. So not very different. So like, and you probably notice everyone talking about like AI agents these days. So like I have some minimum understanding of how like models work, but can you tell me more about like AI agents and like what's required, like how to deploy and AI agents, and can we reuse the same like DevOps, MLOps, AI agent ops practices to deploy and agents?
Yeah, agent, it's a really hot topic today, and let's see what infrastructure and what resources we need to create and deploy AI agent. So AI agent, it's autonomous system which use AI to execute different tasks, to make decision, and to interact with different environments and other systems. Under the hood, we have several components. First component, as you understand, it's AI. We have some of LLMs. It can be our own LLM, which we deployed in our own infrastructure, or we can use some public API like OpenAI or Anthropic or other. Second part and second component, it's orchestrator, which do orchestration of our workers, and in for this we can use different frameworks which are, I think, uh, everyday community create new framework for AI agent. And second part, it's workers. Some of these workers we built in using these new frameworks. For some workers we can build by own, for example, for interact with different systems, so it will be some customizable workers like small scripts. So it's very similar to deploy AI model and then deploy some orchestrator like a traditional application, and then deploy a lot of small applications, small scripts, and we need to manage all this. And also we need to have monitoring, we need to have tracing, we need to provide and organize very good security, because we don't want again to lost and provide to anyone some privacy information. Yeah, so it's very same to deploy and work with AI models, plus work with a lot of different small scripts, and one application which also have different worker scripts and manage them. Of course, additional we need to have some memory, work with have some storage and so on. And but this will be depend. This will depend by agent what it should do.
Fascinating. So, in a nutshell, what I understood is a agent is just my bash cron job on the
Yeah,
server
it's
that queries OpenAI.
yeah, it's something like that.
Fascinating. The more scripts you have, like smarter your agent is, and more things he can do. Yeah, that sounds awesome. I have a million questions, but I think we'll need to leave them for our second episode of this podcast.
Yeah, I think we can think about some future and to do some prediction, and then meet again in, I don't know, in 1 year, and see
What happens? What changes?
Yeah, what happens, what changes. So, if we speak about the future, what do you think near future will be in infrastructure area?
In infrastructure area. I mean, like there will be more different AI-oriented services. I know that like different cloud providers already started to provide your LLM as a service. Like you can spin up Llama and other LLMs like on Google, on Amazon, on Azure. This will continue to happen, but then I believe that there will be some agents as a service that using different models, and you can with some small configuration and inputs you can easily deploy those agents on the cloud. And then like models like the recently OpenAI released this OpenAI operator, which is like I think it's pretty cool. I mean, like you can do some like simple tasks already, and has some troublesome, more sophisticated tasks. But again, like if somebody would tell me like I don't know 5 years, 10 years ago that this would be a reality, I would say like, hey, you super optimistic. I think like a lot of investments right now going to AI space, and you recently heard probably that like US plan to invest into like Stargate project like $500 billion. China is also like trying to keep up, and it's like new competition on like who like I think who will be leader in AI. Like this country will dominate the world.
Yes, this year will be definitely the year of AI agent. We will see a lot of interesting solutions based on them. Uh, Also, I'm sure that we will see a lot of interesting hardware solution specific for AI. Today, everyone mostly using GPUs from NVIDIA. But if you will look at the market, other companies like AMD trying to catch up with NVIDIA. Also, a lot of startups create their own specific hardware which optimize to run and train the AI, ML, LLMs models. So it will be interesting year in this area also. From other side, I'm sure we will see a growing of number of small language models, because for run and deploy these models, we don't need to have so big infrastructure, and it's very good to optimize the cost for infrastructure. And from other side, it's very good to fine tune and improve the model for some specific task. And if we will look at AI agents, we don't need not always we need to have large language models um, in the basis of AI agent. Sometimes we need to have the model with some specific knowledge, and this can help us to optimize and also speed up the work and the speed and performance of AI agents. And it's open also the market for deploy AI agent to some specific not very big hardware, where we can, for example, have some limits of the power, because run big GPU also we need a lot of the power. So we'll see how it will go and what we will have in the end of this year.
And this is a good point. Like, if I need to do like a basic math, then I don't need like an LLM that has an entire Wikipedia in it,
Yeah,
right?
yeah, it's yeah. Good. Yeah. Thank you that you was today with us, and thank you for this interesting and good conversation.
Yeah, likewise, Dima. Thanks for inviting me, and it was like very interesting. And I think we just barely scratched the surface of the topic. And yeah, I will
Yeah.
many more to come. Thank
Yeah.
you.
Thank you.